Hello, Algebra 1. Welcome to the start of Topic 11. Now, Topic 11 on statistics is going to be much focused on Algebra 1 OST prep for you. So we're going to do two parts. So this is going to be part 1, covering dot plots, histograms, and box plots, right? That's typically what, the three types of displays you'll see on the state test in Algebra 1, and then interpreting things. So it's going to be a lot of information thrown at you. It's going to be a conversation here about different things. And again, we believe that the state test is going to make you interpret things, right? So seeing data, can you make some interpretation? So we'll try to talk you through that as we go through these 7 slides. Okay? All right. So let me open up the slideshow. Here we go. All right. So example 1 here. It says compare data sets displayed in dot plots, right? So first of all, what is a dot plot? Well, this is a dot plot down here, right? You have a number line that is labeled, right? So this label is highway fuel efficiency in miles per gallon. And you have a scale, right? So we're counting by ones from 30 to 55, right? And then you have these dots. Each dot represents a car with that fuel efficiency, right? So every data point is displayed. That's what's nice about a dot plot. So for a dot plot, you see each data point. See all the individual data points. So you know exactly how many had 34 as their miles per gallon, exactly how many had 36, okay? So that's very important. Okay, so it says Sawyer has narrowed his car search down to 2 different types of cars. To make an informed decision, he gathers data on estimated highway fuel efficiency, miles per gallon, of the 2 different types of cars. The dot plots show the data below, right? So again, this is an important concept right now in the world because we are in a gas price crisis kind of. So, you know, fuel efficiency is important, right? So if highway fuel efficiency is the most important feature for Sawyer, which type of car should Sawyer purchase? So let's talk about just what the data says, and then we're going to compare means next. So if I look at this data, right, notice that there are a big cluster right here for type 1 between 34 and 38, and then there's this one kind of out here by itself. Sometimes, or not sometimes, but data that's out by itself can be considered what's called outliers, right? Now this does not seem to be an outlier because it's only 2 away from the data. But this we would call a cluster, right? So most of the data is clustered here between 33 and 38. Down here in type 2, notice that this cluster is much more spread out, right? It's not, none of them have 3 dots. At most they have 2. But it goes from 35 to 44 this time, this cluster. This cluster goes from 33 to 38, right? So it's a lot tighter cluster, less spread. But notice that the bottom is kind of shifted to the right, like there's more of the data is to the right in the 40s, right? Whereas this cluster has none in the 40s. And then yes, you have this 51 hanging out here. To me, that 51 would be considered an outlier just because it is several data points away from the rest of the data. So if I'm looking here, again, I think that because the data in type 2 are shifted more to the right, I would choose type 2 because it has an overall higher fuel efficiency. So my answer here would be type 2. Because type 2 has a cluster of data from 35 to 44 miles per gallon. Whereas type 1 is type 1's cluster is lower from 33 to 38 miles per gallon. And again, the state test does not make you type things out, but this could be like a multiple choice question, right? Talking about clusters. And again, just reading a graph. Now, let us remind ourselves how you find the mean or an average, right? So the mean or the average is going to be the sum of all your data divided by the number of data points, right? So we're going to actually do this, right? So each of these dots, so there are 2 33s, 3 34s, 3 35s, right? So I'm going to do this with a handheld calculator. So sorry to not do this on Desmos, right? But I'm going to do, so 33 plus 33 plus 34 plus 34 plus 34 plus 35, plus 35, plus 35. So again, however many dots I see on that number, that's how many times I type that number. Plus 36, plus 36, plus 36, plus 37, plus 37, plus 38, plus 38, plus 41. And for this, I got a sum of 572. So I'm doing 572, and I'm divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 by 16. And 572 divided by 16 gives me 35.75. And that is the average miles per gallon for these 16 Type 1 cars. Now I did the same thing down here. So again, I'll do 35 plus 36 plus 37 plus 37 because there's two of them. Plus 38 plus 38 plus 39 plus 39 plus 40 plus 40 plus 41 plus 42 plus 43 plus 44 plus 44 plus 51. And I got a sum of 644. And when I divide that by 16 as well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is going to be an average of 40.25 miles per gallon. So obviously Type 2 has a higher average of 40.25 miles per gallon. So I would probably pick, that's a 40, sorry. I would probably pick Type 2. Okay, so there's our introduction to dot plots. Okay, next, let's look at what are called a box plot. So in a box plot has what's called a 5-number summary. Okay, a 5-number summary. So when you see a box plot, you're going to see whiskers and a box, like so. So those 5 numbers are going to be the first one, which is called the minimum value, right? Whatever your minimum data value is in your set, that's it. This point right here where the whisker hits the box, that's called the first quartile, Q1. I'll talk about what they mean in a second. Then somewhere in this box you have a line drawn. That's going to be your median, also known as your second quartile. Then where the second whisker meets the box, that's the third quartile, Q3. And then last but not least, this is the maximum data value, right? So when you have a box plot, what it does is it graphically shows you 25%. So this whisker is the first 25%. This first part of the box is 25%. This second part of the box is 25%. And this outside is called 25%. So it breaks it in quarters, right? This box is called the IQR. It is a measure of spread. It is going to be defined as quartile 3 minus quartile 1. And that is meant to be where the middle 50% of your data is. The middle 50%. 500%? No, 50%. And again, a lot of times when we look at data, we want to look at that middle 50% because that's where most of the data is. We don't like to look at the ends where the outliers could be. Now notice here that there are no individual data values except for the minimum and maximum. So again, that's kind of the downfall for a box plot. So you have no individual data values, right? But it gives you a good idea of the summary of the data. Okay, so there is an explanation of what a box plot is. Okay, so let's take a look at this example. It says, Caitlin and Philip go to the neighboring high schools and both are sponsoring charity fundraisers. Caitlin claims that students at her school are raising more for charity than the students at Philip's school. The amounts raised by a random sample of 30 students at each school are shown in the box plots below. Do the data support Katie's claims? So when we look here, right, there's a couple of things to look at, right? First off, you can look at the spread, right? Notice that they both kind of go from 1 to, that's like 25 to 68. So there's no real difference in the spread of the data, okay? But now I look at this box, right? And this box is very concerning because this one is really spread out, contains numbers from, I would say, 32 all the way up to 52. This box is much more compact, right? Including numbers from 41, 42, from 45 to 51, 52, 53, 56. So if you look here, again, this is going to represent 50% of Caitlin's students, whereas this box represents 50% of Phillips students. Notice that these 50% are much more compact, so there's a lot more giving consistently, and it's up here between 45 and 56. Nothing down here in the 30s like Caitlin's. So I'm going to say that Caitlin is wrong because of where Phillips' IQR, his middle 50%, is located. All right, so the question is, do the data support Caitlin's claim? We're going to say no. So an example of how to write this would be the following. The box, which is the middle 50%, for Phillips School is higher, and again, we're just going to compare, right, $45 to $56 than Caitlin's school. And her middle 50% is between 32 and 52, right? And again, I want to talk about this idea of spread. So there's this thing called the range. So the range is the max minus the min, right? Max minus the min. So for Caitlin, the range would be, again, 68 minus minus 25, which would be a range of $43. So that's the amount of giving ranges $43. If we look at Phillips' range, again, as I mentioned at the very beginning, it's the same thing. 68 minus 25, that's $43. But now if we go back to this idea of IQR, right? Q1 minus Q3. For Caitlin, her IQR is going to be 52 minus 32, which is an IQR of $20, whereas Phillips, right, is going to be 56 minus 45, which is a IQR of $11. So again, what this tells you is not necessarily who's giving more, but who's consistently giving more, right? So Phillips' group, his middle 50%, is consistently giving higher numbers because that IQR is smaller. So that's what an IQR can show you. All right. Okay, sweet. So I'm going to stop this first video. I think there will be 2 more videos after this, just because trying to make sure I explain the dot plots, box plots, and histograms as much as we can. So the next video is going to start with a histogram. All right, thanks for watching. Keep tuned in.